Thank you for joining the Building Energy Hub for this webinar. We're excited to have Thomas Manjares from Peoples Gas and North Shore Gas talk to us today about micro-combined heat and power systems. But before we dive in, just wanted to say hi. My name is Rimjim Agrawal. I am the program manager at Illinois Green Alliance, and I manage the Building Energy Hub. Before we dive into our content for today, I just wanted to give you a quick intro of the Building Energy Hub. You may already be familiar with us, but the Hub is a project of Illinois Green Alliance, and we're supported by a network of partners, including Elevate, the Climate Bank, ComEd Energy Efficiency Program, and the City of Chicago. We're Illinois' trusted resource center for building professionals that are seeking practical solutions to improve building performance. So throughout the year, we do a lot of education and trainings. We support multifamily and commercial building owners, developers, operators, and property managers with free resources, some technical assistance, and also work municipal and community partners as they plan, finance, and implement building retrofits across Illinois. For today's conversation, we're really grateful to have Thomas for talking about a new energy efficiency technology, the micro-combined heat and power systems. Couple of housekeeping notes before I turn it over. Please use the Q&A feature to put in any questions. We'll take questions at the end of the presentation. You can also upvote any questions that you agree with and want to ask. Stay tuned. We'll be putting in some resources into the chat. And with that, I'm going to turn it over to Thomas.
Great, thank you. I'm glad to be back here with Illinois Green and the Hub. And boy, what a great time to talk about combined heat and power on the heels of some tornado warnings here in the area. So, spoiler alert, there's combined heat and power. These micro combined heat and power systems are a great way to keep your critical loads up and running in the case of an unfortunate event like a grid outage. Next slide, please. So before I get into the details of the technology, just want to give you a quick overview and hopefully a reminder for some of you of who we are and what we do. So our North Shore Gas service territory serves natural gas customers in Lake County. We've been doing it a while, celebrated our 125th birthday last year. Our Peoples Gas service territory is highlighted in green there. It's just the city of Chicago proper. We've got about 1 million customers combined. So if you're in one of those areas and you're looking for direction on how you can be more energy efficient, that's what we're here for. Next. We've been running these energy efficiency programs for 15 years now. So I tend to think we're pretty good at it. We've got something for everyone. So I've highlighted some, here are some highlights for business and public sector customers. If you're a resident in our territory, we've got solutions for you as well. Something that's a little bit different about how we do things here is we really take a concierge approach to energy efficiency. So if you have an idea, our job is to help make that idea a reality. And so these micro combined heat and power systems that you're going to learn about today are definitely a custom approach to energy efficiency. There's a lot involved, but we've got the experts. You just bring the interest and we'll take care of the rest. Next slide. Okay, so let's get into it. What are we actually talking about here? As Rimjim stated, this is a newer development, but the idea of a combined heat and power system has really been around as long as there's been electricity. And so when we talk about combined heat and power, we're just talking about generating electricity and useful heat at the same time from a single fuel source. The innovation has really been shrinking that technology down to something that you see on the right, something that's so small it can fit in almost any boiler room. What you're looking at on the right there is a 4.4 kilowatt Axiom mCHP system. That means it puts out 4.4 kilowatts of peak power. It's about the size of a mini fridge. So again, if you have a boiler in your building, chances are you've got room for a micro combined heat and power system. With these micro CHP systems, it's the way that the cycle operates is electricity is generated first through combustion of natural gas, and as a result, you've got all this great heat left over in the generator exhaust. So we capture that heat and we use it to produce hot water. Once you have the hot water, you can do anything you want with it. So if you're a small manufacturer and you've got higher temperature requirements, these can produce water up to 180 degrees. If you need water hotter than that, this is still an option. We can do a little bit more work on the back end to upgrade that temperature even higher. But the examples that I want to show today will be mostly domestic hot water heating, which I think pretty much everyone on the call has in their facilities. And it's a good sweet spot and a good entry point for the technology. Next slide, please. So, I'm here representing the energy efficiency programs. I'm the technical lead for both our Peoples Gas and North Shore Gas energy efficiency programs. So I just want to remind everyone that we're talking about an energy efficient technology here. So it's not just how can we generate some electricity on site to save some money on our electric bills. What we're really interested in is doing that as efficiently as possible. So again, there's a lot of ways to do this, only a few ways to do it efficiently. And so if you're interested after this, if you're interested in learning more, kicking the tires, seeing if your building is a good fit, definitely reach out to us first. We have services that we can provide. We can take a look and we'll be honest, not everyone is a perfect fit. A lot of people are a good fit, and then some people aren't a great fit. But at the end of the day, what we're doing is really we're eliminating all of the losses and the inefficiencies on the electric grid. So you're taking the power plant and you're putting it in your boiler room. When you do that, there's a pretty big emissions reductions, especially here in Illinois, where a majority of our electricity still comes from coal and natural gas. So the thought here is you're using natural gas to produce electricity already. And that's being done far away. If we bring that closer, if we bring that on site, we'll eliminate the transmission and distribution losses on the electric grid, and we'll also be able to capture the byproduct of that electricity generation, which is usable heat. If you look on the bottom right here, sorry, just a quick explanation. A lot of stuff on these images. On the bottom right, we're modeling a system where you've got a 95% efficient, super efficient condensing natural gas boiler, and you're using grid electricity in your facility. When you add that all up, because of the inefficiencies of the electric grid, your total building efficiency, total system efficiency is about 35%. If we replaced that system or installed next to that system one of these combined heat and power systems, what we see is there are still some losses, some energy required to get the natural gas from out of the ground to your facility. But that's much less than what happens on the electric grid. So when you replace that efficient boiler and grid electricity with a combined heat and power system that generates your electricity and the same heat output that the boiler was providing, you can get to total facility system efficiencies around 90%. So definite improvement in overall energy efficiency, and then also can be significant reductions in emissions, especially when you look at when the combined heat and power system is operating versus what's generating electricity on the grid at that time. Next slide, please. The next biggest reason why to look into this is cost savings. So energy prices are increasing. It's an unfortunate reality, increasing across the board. But recently, what we've seen is, although gas prices and electricity prices are both increasing, electricity prices keep increasing faster than gas prices. So now we're at the point where pretty in a majority of places throughout the country, using natural gas to produce your electricity pencils out to be cheaper than buying grid electricity. There's some places where that's not true. Here in Illinois, it's definitely true. We've got a spark spread of about 3.5 to 1. So for every kilowatt hour that you can generate with natural gas, it's about 3 times cheaper than what it costs you to buy that same kilowatt hour from the grid. Next slide, please. And then the other big reason why people are turning to this technology is to preserve what we'll say is not preserve, but maintain critical loads. So if you've got certain processes in your facility that you just can't afford to lose, what can be done is those can be connected to a critical loads panel right next to your main electric panel. And then that critical load panel is connected to the grid. It's also connected to one of these micro combined heat and power systems. And so now you've got double redundancy. If the grid goes out, you can maintain those loads with the mCHP system. If it's time for an oil change on the mCHP system, system's down for maintenance, you're still connected to the electric grid. And again, one of the big advancements here is that third bullet point, what we call black start capable. So in the event of an outage, these can start up without relying on grid electricity. That's a pretty big innovation, pretty bold statement for these smaller systems. So if you have some critical loads, if you're considering a backup generator, well, what we would say is you should consider an mCHP system. It's more efficient than your backup generator, and it gives you all those same benefits. So you could even think of it as, it's your backup generator running all the time. And then your backup becomes the grid. Next slide, please. Okay, one more. Okay, I won't go into this too much, but again, this isn't as plug and play as just replacing a boiler. We understand that, but we're here to help. So what our programs do is we offer engineering studies up to $20,000. We cover the cost of sending an expert out to do a full assessment of your facility, all the way down to even generating the mechanical drawings for how an mCHP system would be integrated. Next slide, please. Okay, so we kind of get the why. I want to look at two specific examples that went in our Peoples Gas service territory last year to show you kind of some of the benefits that our customers are already receiving, and then give you a good frame of reference for what you might need if you wanted to replicate this at your facility. Next slide, please. So I've got two projects, two award-winning projects, actually. The first one is the mCHP installation at Half Acre Beer Company. So this is a local craft brewery here on the north side of Chicago. This is also a tap room and restaurant. So as you can imagine, they need a lot of processed hot water to run the brewing process. They also need a lot of domestic hot water to keep the tap room clean and to keep the kitchen up and running. So great opportunity for mCHP. It's also requires a lot of electricity to run a restaurant and also a brewery. So again, if there's a large hot water load, there's a large electric load, really great opportunity for multiple systems. And so that was what was installed here. You've got two 25 kilowatt generators. Those are the cabinets with the blue lid. We've got domestic hot water storage tanks. Again, the great thing about this mCHP technology is its modularity. So you can really dial in, okay, how many systems do we need? How much hot water storage do we need? Do we need to add any? Can we use the existing storage? All of those decisions kind of add up to your total system efficiency. So again, it's a bit of a process to evaluate all of that, but you reap the benefits upon installation if you do it right. For this one, we're looking at, this meets about 60% of their total hot water load. Electricity, as you can see, 138 kWh a year. That comes out to be around, we're anticipating about $18,000 worth of operational savings a year. And total system efficiency based on initial measurement and verification, it's about 93%. So definitely a good return there. Next slide. Oh, great. And here's an example of, again, what our programs can help you achieve. So this was a result of our engineering study. They got down to how many units you're going to need, how they're going to be, how much hot water storage are you going to need, and how that gets integrated with the existing hot water heaters and connected to the rest of the plant. Again, if you're interested, we can bring out the experts to see if it makes sense. Next one. This next example is a high-rise apartment building down in, I believe it's in Hyde Park. Really beautiful building. 124 unit multifamily property. So as you can imagine, there's also a laundry room in the basement. So they've got pretty significant common area electric loads. and then it's also a central hot water system. So the units are, you know, individually metered, but the hot water is produced centrally and distributed throughout the building. So 124 units, there's a lot of circulation losses. Hot water is a pretty big thermal load. For this particular property, it made more sense to go with two of these Axiom, these smaller Axiom units. They are producing the domestic hot water. Um, right now, it's meeting about 50, a little over half of the thermal load, just about 20% of that kWh load. But as a result of our measurement and verification process, to actually figure out these numbers, we think we've identified some areas for improvement. Again, some changes where we can bump that hot water number up, closer to 70, 80%. And so right now, for this facility, looking at operational savings around $6,000 a year. But again, we think we can do a little better. Maybe get that number around $9,000, $10,000 a year. Okay, I think I have one more after this. Yes, okay. So those are two quick examples, but that's just because that's what we've been able to do so far. Doesn't mean that those are the only two building types, only two use cases. So really, what we're seeing is, yeah, anybody that has a boiler and uses electricity, there's probably an mCHP technology out there that can fit with your building. Multifamily, definitely a big one. Other ones are things like hospitality venues, hotels, health and wellness. Pretty much anybody except for a hospital. Makes sense. If you're a hospital, you use a lot of steam, and these systems don't generate steam, at least not yet. There are other technologies very near to market that will be generating steam. So I hope to be back in a year or two talking about that technology. But yeah, somebody asked me before, why aren't these? They make sense. Why aren't they everywhere? I mean, my response was, yeah, they do make sense in a lot of places, but people don't know enough about the technology yet to really make the leap. So our goal is to be out here talking about these projects, learning from them, learning from you all, doing assessments, and really honing in on, if you are a good fit, let's get you, let's figure out a way to help you install that technology. Okay, and I think that's all I have. So yes, we've built out a whole section of our Innovative Ways to Save website to talk more about this technology. But if you're interested, definitely reach out to us. We'd love to talk to you about it.
Thank you so much, Thomas. That was really helpful. Great to learn more about the technology and different applications and how to use it, and also very helpful to see those examples. I see that we have a few questions that have come in. So first question is, what are the expected paybacks on the two projects? I think you answered about the savings, but I don't know if payback is something that you have calculated or are familiar with for those
Yeah, I
projects.
don't have those numbers off the top of my head, but let's take that as a follow-up. Should have had
Okay,
those.
sure. And then another question from Donald is, could these work for a smaller data center with the number of modular units?
Yes, absolutely. They're already being used for that purpose. Absolutely. There
Do you
are.
have any examples of where they're being used or what size of data center?
So I think what the question is probably asking for like a smaller on-site part of a building. If you're building a data center, you don't need a micro combined heat and power system. You need the multi-million dollar, size of a shipping container, um, combined heat and power systems. And those have been around for a while. Um, Lots of experts in the field, well established. People know how to use those. Um, but these smaller, on-site data centers, we're going to start to see those popping up more and more. And yeah, this would be a great fit. I can't think of um, where the installation is exactly, but I can close my eyes and I can see a picture of those same EC power units that were installed at the brewery. Um, I can you can get those daisy chained together, and even if you don't have space inside to do that, they can put them together in a shipping container. That's all wired together, all hooked up. They just drop it off in the parking lot, next to the dumpster, and just connect to your building, and then those all operate as needed.
Great. Thank you for that. Another question from Ree is, what are the ideal unit requirements or size range that is the most efficient for this setup?
The answer to that is going to be wherever you can have these things running like almost constantly. So the the sizing process is you look at, okay, what is your thermal load? What's your thermal load profile? What is your electric load? And then you try to base load that thermal load with one of these mCHP units. So some of you are probably thinking, well, it was only 55% of the thermal load for the multifamily building. So if you guys would have installed more, you could have gotten to 100. Well, you get to a point of diminishing returns where, sure, we could have, but the way that domestic hot water load is, you've got your recirculation losses and some loads throughout the day, and then right before they're leaving for work or right when they're getting home from work, you got these big demand spikes. And so those are being met by the existing water heaters. The mCHP systems are what we call base loaded, and so they get to run pretty much 24/7, generating heat and electricity. So that's what you want. You want them running as much as possible.
Yeah, absolutely. That makes sense. Ree, if you have any follow-up questions, please feel free to ask. There's a few questions from Rajiv. First question is, any installation at the public sector or office buildings? I would assume they are suitable for those buildings, but are you familiar with any examples, or do you think public sector buildings are an
I
application for
will
this?
I will say kind of. I know of an installation out in Joliet that Nicor Gas did, and that is at I believe it's an Army National Guard facility. So we don't have any yet. If you have some candidates in mind, we'd love to take a look.
All right. Another question is, if you replace emergency generators, can customers export the power to the main grid and take advantage of reimbursements like solar PV through net metering?
That is a fantastic question. We're still trying to get to the bottom of that. So the short answer is, if you're in a place where you know you can do that, that's a fantastic opportunity. Our sister utility in Milwaukee, Wisconsin, We Energies, is a dual fuel. It allows customers to do that. We got a whole nother case study on that. Here in Illinois, it's a little murky, and we've been trying to get some more clarity from ComEd on when can a customer export, when can't a customer export, and the goalposts are changing on their side as well. So one of the things that we would like to do is, reach out to us and we'll start those conversations. because it might even be a site-by-site basis, just depending on what the ComEd grid looks like.
Yeah, thank you for that. There's another question. I don't understand. Rajiv, would you like to come off mute and ask this question? I don't know if you can see the chat, but it says turbine life, speed and vibration issues due to centrifugal inertia, like big turbines.
Yeah, that's actually a good question, thoughtful question. Neither of these are both reciprocating engines. Neither of them are micro turbines. There is another company called Capstone that has micro turbines. We haven't done any projects with them yet. So this is a small natural gas engine, and I looked it up before getting on this call. The decibel level of the bigger units is right around 50 decibels, which is there's code requirements for residential air conditioners, the condensers that go outside your window. And I think the max on one of those is like 65 decibels. So I like to tell people that it's quieter than an air conditioner. And in fact, when you're in a facility like Half Acre Brewery and they have those things running, you can't even tell unless you open the lid and you see some moving parts, just because of how quiet it is relative to the rest of the tap room.
Yeah, thank you for that. I hope that answers your question, Rajiv. And I don't see any more questions coming in, but if you have any questions, please feel free to email us. And I think Thomas will be happy to answer any questions. Okay, I see a new one. Is there an option where a unit creates heat for air rather than for heating water?
Yes, that's an option. That's an option as well. So it's basically you can put a radiator on there. You can use that heat to produce hot air. For us in these applications, the domestic hot water was the best because that's a year-round load. So it can be done if you're only using it for seasonal space heating, then you're probably going to run into problems on payback period. It'll work, it'll be efficient. It just might take you a while to recoup that investment. It would be better if you could, in the off time when you're not needing space heating, if you're also using that for water heating.
Thank you. That's helpful. We really appreciate you joining us today. The Hub has ongoing education programs happening, so please look at our education calendar, sign up for our newsletter, follow us on LinkedIn to stay connected and to learn more about emerging technologies, financing programs, or if you want to learn about case studies or share your own case studies, we also have a podcast that we share insights from experts and real world projects. So we hope that you find ways to connect with us, and please reach out to us if you have any questions or would like to learn more about certain resources on our website. Thank you, Thomas, for that great presentation and for answering all of those questions. Thank you all for joining us this afternoon. Hope you all have a wonderful day.